It's also, as we just saw, a slope function. So it allows you the opportunity to find the slope at any point, right? It's a slope function. Very good. Okay, so here's all our notation, okay? So I've got f prime at x. There's my Lagrange notation. Then I have my function notation, y prime. And then I have my Leibniz notations, which is dy dx or d over dx. Remember, if you're using d over dx, you got to write the function, right? Because what are you taking the derivative of? You have to write it there. Okay? All right. Some shortcuts to calculating derivatives. See textbook pages 76 to 79 for the proof of each shortcut below. So I will show you some of the proofs, but I can't show you them all. They're very simple proofs, that's the main reason why. But go ahead and take a look in your textbook. I encourage you to do that. Go and take a look at the proofs in your textbook. Okay, so the first rule I'm going to show you is called the constant function rule. So let's say that you just have a horizontal line, because that's what it is, right? That's what a constant function is. So I have f of x equals k, just any number, a horizontal line. Then my first derivative will always equal 0. I showed you that in the last example, so let's take a look now at the proof. And in order to prove something, we have to go back to chapter 1 first principles. Okay? So to find a shortcut, you have to prove that the shortcut works by the original rule, the original law. Okay, so let's do it. What's my function? Yeah, my function is k. It's just a number. It's not an x. It's just k. So my function is just k. So this becomes k minus k. And k minus k gives me 0 in the numerator. And 0 divided by a number is just 0. Again, I'll say it again. K is just a number. It's not an x value. So I can't do x plus h. It's just a number. It doesn't. But I don't even have to take the limit because 0 divided by, look, I'm still taking the limit here. I'm taking the limit of 0. You get it? Yes. So maybe let me add that in, just so you guys can see that. I'm going to add that little step in. Yeah. So what's happening here is you're still taking the limit, but it's just 0. So the limit of 0 is just, it's a constant, it's a number, right? So when you're taking the limit of just a number, we learned that in the properties. It's just, okay? Okay, so now let's look at some examples. So I want to find the derivative. I want to find the slope function of 3. What does it equal? It just equals 0. As simple as that. You just write 0. Now, you got it. You got it. The slope of a horizontal line is 0. Yeah?
Wait, miss?
Yeah.
Like, because this, I know, like, this gets kind of into, like, the formulas for, like, I mean, like, it's similar to, like, how you would use, like, trigonometric formulas and stuff, with, like, derivatives. So, like, why don't we start with this, and why do we start with, like, the previous things?
Because the previous way is the proper way. Like, the shortcut is just a shortcut. Like, even when we solve equations, right? Like, you hear me say, oh, we bring this over to the other side, and that's not really what we're doing. We're not bringing anything to any side. We're adding a number to both sides, or we're subtracting a number from both sides. We're just saying that to be quick about it, right?
Okay.
To not have to do every single step every time. But the actual real way to do that is to add to both sides or subtract to both sides. But we all know that by now. We've learned that in grade 9. And it's the same with this. You have to understand why we can now use these shortcuts. So that's why we start with the actual way to do it, and now I'm showing you the shortcut.
Okay.
That make sense?
Yeah, it's just the last way is just so annoying.
I know. It's first principles. It's a lot of work, but hey, you got to do it. And when you take first year calculus, they're going to show it to you again. Right? First principles. Very important. Okay? Especially for proving, guys. Like I said, when you're proving, that's when all these properties become so important because you have to use them. Right? In high school, no. We used to have more. They were still just baby proofs, like they weren't anything crazy. But in university, there's, I mean, it gives me the math degree, it's all proving. Like that's what you do, right? That's, what I'm doing. So now, what was he doing? You got it, that's right. He was getting instantaneous law. So he must have been, if he drew a straight line, a horizontal line, then he must have been at a maximum limit, right? Okay, we're gonna learn that, don't worry. Okay, next, the power rule. So what does the power rule say? Okay, so follow me here. You have x to some exponent n. The shortcut to finding the derivative is drop the number, which is the exponent. Keep the function, the x, right? Your variable. And now the exponent, you subtract 1 from it. Now it sounds complicated, it's so easy. Watch, ready? We're going to do it here. So I'm going to take the first derivative. So what happens? The exponent,
3x to the power of 2.
the x stays. And now you do 3 minus 1. And I mean, you don't have to show this, but I'm going to show it now for the sake of the lesson. And the derivative is just 3x squared. That's much quicker than saying the limit as h approaches 0 of, right? X plus h, all cubed, minus x cubed. This is much quicker. It's a shortcut. Okay, here I have y equals, and so I'm going to say y prime equals. Now, before I take this derivative, I want to make my life easy. So I'm going to simplify this. I'm going to simplify this. How can I simplify this? How else can I write this function?
You missed.
You got it. X to the exponent negative 2, x to the power of negative 2. So when I take my derivative now, ready? Let's do it. The exponent comes down. X stays. And now we subtract 1. So my derivative is negative 2x to the exponent negative 2. That is my exponent. Okay? And if you want to make that exponent positive, you can, like so. Negative 2 over x cubed. Notice the negative 2 thing in the numerator. Negative 2 has an exponent of positive 1. Doesn't go down. That's a big mistake that students make, so be careful. Okay, y equals x. What would the derivative be of y equals x?
1.
Good. Why? Because the exponent is 1 here. So the 1 comes down. Now you have 1 minus 1, which is 0. Anything to the exponent 0 is 1. You do not have to write all of this. So whenever you see y equals x, you know the derivative is 1. This will become second nature to you. As you do the homework, you're gonna pick this up very quickly. Are there any questions so far? Okay, so that is the power rule. Okay, little shortcut. And what are we finding in all these cases? I know I asked you guys the same questions over and over, but it's to help them stick into your brain. What are we
Slope
finding?
function?
Yeah, good. We're finding slope function. Right? We're finding the slope function every single time. Very good. Constant multiple rules. The rules sound more complicated than what we're actually doing. So here, we now have a number in front of the function. Okay, that's all this is saying. You have a number in front of the function. So just take the derivative like normal and then multiply that number in. That's all this is saying. So for example, if I have this, don't worry about the 3. Just take the derivative as you normally would. The 2 comes down. X, I have to subtract 1. So 2 take away 1 is 1. Are you guys okay with me just doing it like this? And so now it just equals 6x. And yes, you can do this in one step. 3 times 2 is 6. So look over here, h prime of x. This rule is saying, don't worry about the constant, leave it alone, find your derivative, multiply in the end. So again, what did I do here? Negative 4 came down, x stays the same. Negative 4 take away 1 is negative 5. And so now I have 28, x to the negative 5, which would be 28, over x to the exponent. Are there any questions so far? If there's time, I'll show you the proof for that guy later. If there's time. Okay? I'll show you the proof for this one, just to show you how a proof works. You are going to see some proofs along the way, and we'll show you some. But if there's time, I'll show you this one. I don't know if we're going to have it. Okay. So there's this one. Are there any questions so far? Are you guys good? Everyone good? Another little shortcut. Okay, sum and difference rule. Well, now I have a whole bunch of, it's a polynomial. So I have a whole bunch of terms together. So what this is saying is, well, that's okay. Just use the power rule individually for each of these. Use the power rule individually for each of these. So when I go to take the derivative, I want to make sure that my polynomial is nicely simplified to make my life easy. So I'm going to change this to this. I make that exponent negative. I get rid of the fraction. It makes my life easier, yes? Good. Now, I take my derivative. And here, I'm going to use a different notation, just to be different. I'm going to use dy dx. And when I take the derivative here, who wants to try it?
Me.
Go for it.
10x
Good.
minus 2 or plus
Good.
2
Yeah.
x to the power of negative 3
Good.
plus 6.
Oh, somebody's learned this before. Okay, ready?
Mhm.
So it's good, it's good. 2 times 5 is 10. X stays, 2 take away 1 is 1. Okay? Over here, negative 2 times negative 1 is positive 2. The x stays. Negative 2 take away 1 is negative 3. Plus, the derivative of x we saw was just 1. So 6 times 1 is just 6. You guys good? Be honest. Yes? Like I said, this is going to become second nature to you. Do you need me to show some extra steps in here? Because I really just did this bam. Do you need me to show an extra step in there? Okay, good. Okay, so let's do some examples. So here I have 32, x to the exponent 25, with a root. It's a fifth root of 5. What should I do? What do you guys think I should do? We didn't learn how to do this.
Put it into exponent.
Yeah. The power rule is showing us how to work with exponents. So let's change this into exponential form, right? And remember, we know that that means it's 1 over 5. All right. We can still simplify this. Can't I? Can't I simplify this further? You don't have to. You can take your derivative from this point. Well, no, you can't yet. No, you will be able to. But for now, let's simplify it. So how do I simplify this? That 1 over 5 has to go to both. What is the fifth root of 32? Oh, come on, you guys don't know this. Sorry? 2. Look how nice and simple that function became. Now when I go to take my derivative, it's just 10x to the exponent 4. Okay, again, here, eventually, you're gonna know how to derive this like this. But for today, you don't. So what do I need to do so that I can use my rule? Yeah. Yeah. 40x cubed. So then you're gonna find what's called a second derivative. And we're gonna learn that too. And then you can find the third derivative, and you can keep going. Yes, you can keep going. Until you eventually get to 0, right? Yeah. But you know what? We're not going to talk about it in terms of a slope of the slope. We're going to talk about it in terms of position function, velocity, acceleration. Yeah, we'll talk about, let's not get ahead of ourselves. Okay, so I want to be able to use my rules here. The rule that I learned deals with polynomials. Let's make this a polynomial. So I'm going to expand. Calculate. So now, when I multiply the same base times, what do you do to the exponent? Yeah. And now, what's going to happen here when I multiply? Oh, come on, guys. Everyone should know. Somebody yell it out. Thank you. 3x squared. Yes, everyone should know how to simplify that if you're in this class. Okay, now we're taking the first derivative. So I take the derivative. Who wants to do it? You want to try? Let's do it together. Go for it.
5x to the power 4
Awesome.
plus 6x.
Amazing. The 5 comes down. The x stays. Take away 1 from 5. Then the 2 comes down, gets multiplied with the 3. That's 6. X. 2 minus 1 is 1. Very good. Next one. Again, I want to make my life easy. What should I do here before I take any derivative? Yeah, how would I rewrite that? Beautiful. Okay, who wants to do derivative? Who wants to try taking the derivative? Thank you, Effie. Go for it. Good. So 3 over 2 times 2 is the same as 6 over 2. And 6 over 2 is just 3. Very good. And then? Okay, so I'm going to show this just to help you guys out. So this is now 3 over 2. But I have to subtract 1. And 1 is 2 over 2. Okay, so we'll clean it up in the next one. Hold on. Okay, we'll come back to it. Next, do the next one. Yeah? Good. And then the next one? Exactly. Good. Yeah, to 0. Okay, we got to clean this up now. My first term, so I have 3 over 2 minus 2 over 2. And so this is equal to 1/2. And no, you do not need to show that step. Cool? Okay. F of x equals 5 times x.
You missed the exponent. I mean, the negative on the exponent.
Where? Oh, thank you. Okay, f at x equals pi times x. What do I do? Oh, very good. People get confused when they see this because everybody thinks of pi as a variable. But pi is just a number. And so because it's just a number times x, and so it's just pi. Just a number, right? Okay, g of x equals pi. What's the derivative here? Good. Do you know how many times on a test I see 1? It's 0. It is not a variable. It's just a number. Okay, so be very, very, very careful, okay? Okay. pi squared?
0.
Good. Can I get you guys? A lot of people, when they see this, again, you're on a test, right? You're nervous. And you write 2 pi. Well, pi is just a number, which is 0. Good. Okay, and now this one. Good. This 2 goes to the front. You leave the pi squared, it's just a number. So 2 multiplied by pi squared, and then times. Very good. Yes. Well, it's always x one, right? But we're always doing with 2 dimensions. No, no, not right now. Not right now, no. Okay. Example 2. Find the coordinates of the point on the graph of y equals 2 over x, at which the slope of the tangent is perpendicular to 3x minus 5y plus 3 equals 0. What do I do? So, yes, I'm going to highlight that word. That's an important word, right? Perpendicular. So let's look at that first. So right away, we know that we need the slope of the tangent that is perpendicular to that line. So perpendicular to this. So guys, remember back from grade 9. How can I just look at this and tell what the slope is? Which 2 terms do I need to look at? A and B. So let's recall. For slope of standard form, n is equal to 1. Who remembers? So negative A over B. Negative A over B. Okay? So my A right now is 3. So it's negative 3. My B is negative 5. And 2 negatives give me a positive. B is negative 5, yes. But A is positive 2. So now I have to make it negative because that's what the formula tells me to do. Which makes sense. If you think about it, guys, y equals mx plus b. If I have to solve this for y equals mx plus b, that has to go to the other side. Right? Okay, and then you gotta divide to solve for y. Right? That's all it is. Okay, so now I have a slope of this line, but I need the equation of the line, or I need to know the x-coordinates of the tangent that is perpendicular to this. So what's the slope that I want? That's the slope that I want. What do I do next? Find the coordinates of the points on that graph that has this slope. What do I do? Okay. You take the derivative. What does the derivative give you? Gives you the slope function. From the slope function, you can plug in a point to get the slope at that point. We're going backwards. I have the slope at the point. I need to know what the point is. So what we're going to do is we're going to take the derivative to find the slope function. We're going to set it equal to the slope that we need, which is negative 5 over 3. And now we're going to solve for that one. And we're working backwards. Right? You're going to take the derivative. Yes, take the derivative. Go for it. So we're going to start by finding the slope function, yeah? So I take the derivative. What's the derivative of this? Good. It's this. That is my slope, which is the same thing as this. That's the slope. That's your slope function. Remember that. Very important. Exactly. You got it. So now I know the slope that I need, but I don't know at what x value. So I sub in the slope. This is just slope. So I sub in the slope. Which is, what was it? Negative 5 over. And now I solve the x. And I know at this value of x, that's where the slope will be, negative 5 over. So I'm going to cross multiply here. Two negatives make a positive. And when I solve for x, I have to take the square root. Now, when you're solving for an x, and you're taking the square root, you always have to put plus or minus. Because if I'm trying to find out what x values can give me the square root of 4, well, I don't know, is it plus 2 or is it minus 2? Because both work. So you've got to take all our options. So you have to take your plus or your minus. Okay? So these are the x values now, where the slope will be negative 3 over 5. There's two of them. That means there's 2 points on our graph where we have a slope of a tangent that has this slope. The question asks for the coordinates. Not just the x coordinates, but the coordinates. So what do I need to find? I got to find y's. But that's not hard. How do you find y's if you know x's? Yeah, that's it. You're just going to put it in the equation. So now we need to find y value. These are the x values. So for these x values, I need to find the y value. Okay, so I just sub into the original function. The original function is 2 over x, or 2x to the negative 1, right? It's the same thing. So remember, guys, this is just a division line. When you're dividing a fraction, what do you do? When you're dividing a fraction, what do you do? No. You multiply by the reciprocal. I'm just dividing a fraction here, right? So this is the same thing as 2 over 1 multiplied by the reciprocal. You see that? So this now equals 2 root 5 over root 6. We're going to rationalize because I'm giving a coordinate. And now I have, can I leave it like this? No, you have to simplify. And so this becomes 230. So that means my point is, again, I'm going to also rationalize this. So if you rationalize your x, as we just saw, it's going to be root 30 over. And here we have. Okay, so that's your point. And then you do the same thing for your other x value. And the other x value is just the same but negative. All right. You guys notice what this thing is doing? You see that? It's glitchy. Okay. So here, same thing. but now it's negative. Are you guys okay with me sticking with this stuff? It's the same thing, right? Yeah. Okay, and so therefore, are there any questions? Okay, and so just so you guys, I want to show you this function, just so you can understand. It's always nice to visualize your function, and so I'm going to use Gizmos to show you. I'm sorry? It is. This one's amazing. I love this program. No, no, you're not allowed any graphing technology during the test. Cancel it. Okay. Oh boy. What is going on? Okay. The white, not listed. Connection's not listed. So what was the function? It was 2 over x, yes? Okay. So here's your function. Okay? So what you're noticing here, you have 2 branches to this function. And so you see how this is a symmetry? Well, it has point symmetry. Yes, you guys see that? So we have the exact same shape, just in different axes. So what's going to happen here is you're going to have the same tangent. So we have a tangent that will equal, what was it, negative 5 over 3 at 2 places. And we saw that those places were positive and negative root 30 over 5. Yes? So what you're seeing is, I'll just make it up. You're seeing that you can have a tangent here, and I don't know if it's here, or you can have a tangent. Oops, they don't even look the same. But they would be the same, is what I'm trying to say. You have 2 parallel lines, okay, going at different points. Let me draw them better.
Because actually you can do out the figure and take out your figures of the 4 line and the 6 point of the
Anyways, I can't, it's hard for me to do on the smartboard. So you understand what I'm getting at, right? We have 2 branches, and you're gonna have 2 parallel lines that have the same slope. So there are 2 locations on your graph where you have that slope. Okay? This is bad. That's what you can't, right?
and you can have 2 other figures and you don't have to solve that.
I'm sorry?
You can have other figures and you don't solve it figure.
No, but I'm trying to show something. I'm trying to show that at a certain point, you're gonna have 2 of the same slope. But I'm having difficulty with it. Okay. I don't know where it is exactly. I'm just trying to show that on this graph, there will be many tangents that are parallel. Yes? We found a specific one. I didn't draw the specific one. I'm just trying to show you that there are 2 that are parallel. And these are not the only 2. I can go to so many different points, and you're going to find parallel tangents. Okay? Okay. Do you want to try doing it? Like on a smartboard, it's very, very, like you see, I'm scrolling down and it's writing on my, it doesn't allow me to get it exact, right? So it's, I'm doing my best. What can I tell you? Okay, I hope you get the idea. Okay? All right. Yes, correct. So whatever equation we got, then you're finding the perpendicular to that equation. But those two are still 2 points on your line. Yeah. Okay, guys, so your homework for this section is this. Okay, so I will be posting these, so you will have the homework in the classroom. I will also post whatever solutions I have to the review. Okay, for chapter 1.
Miss, can you scroll up for the last solution, please?
Yeah. Is that good?
You have all the solutions.
No, not all. If you want all of them, go to that Prep Anywhere. Prep Anywhere should have most of them there. I have whatever solutions, Hassan, I took up in class. So whatever solutions I've taken up in the past, I have to. Is that good? Are you guys done talking it? So are you guys done with this? May I take it down?